Alright, as with our last limiting reagent quiz, several people have asked if I could go over the answer because they found it a little bit difficult and confusing and didn't know where to start or how to finish or whatever. So, as usual, I like to be as helpful as possible, and so here we go with a little video answering the question of what's going on here with this quiz. So we're given a certain amount of magnesium and a certain amount of silver nitrate, and the first question is what happens. So if we write formulas, magnesium is a metal and it's a solid, and you drop that into a solution of silver, which is always +1 in its compounds, and nitrate, which is NO3 1 minus. So we just need one silver and one nitrate, and all nitrate salts are soluble. So this is aqueous. So you have an aqueous solution of silver nitrate, magnesium solid, and those two react. If you're familiar with the types of reactions, a pure metal plus a salt, there's the possibility for a single replacement, which would give you silver plus the magnesium nitrate salt. Now, since the magnesium will form 2+ ions, you need two nitrates with the magnesium, and again, all nitrate salts are soluble, so that will be aqueous, and then the silver will be solid. So I've written the formulas for the products correctly, formulas for the reactants correctly, and if this magnesium is more active, which it is, silver is one of the less active metals and will often precipitate. Now I just have to balance. So I have nitrate on the right, two of them. I need two nitrates on the left. And then the two silvers, 2 moles of silver nitrate can give us 2 moles of silver metal. All right, so there's the balanced chemical equation. And as with any stoichiometry problem, if they give us amounts of two different materials, they can react, and we want to know how much product we can make, how much reactant is left over. And this one is a particularly difficult limiting reagent problem because it asks how much solid will be left at the end of the reaction, and if we have any leftover magnesium or any silver that was formed, those would be solid. So if you filtered off the solid and wanted to know what should be in there, there's the potential, depending on what's limiting, for there to be product solid and leftover reactant solid. If you wanted pure silver, it would be wise of you to add in less magnesium so there's none of this left over. But it looks like somebody threw in a big honking 3.8 gram piece. How many moles is that and whatever. So again, any stoichiometry, so this is a stoichiometry problem, which is just a fancy word for how much. Stoichiometry problem, we want a balanced chemical equation. Now we're going to convert to moles. So 3.8 grams of magnesium, 1 mole of magnesium, 24.3 grams, I believe. Let's check the correct table. 24.31 grams per mole. We can throw in another sig fig, not that we need it, because our balance wasn't very good and only gave us 2 sig figs there. But we take the mass of magnesium, 3.8 grams, divided by the molar mass, 24.31 grams per mole, and we have 0.156 moles of magnesium in there. And if we want to know how much solid we could produce from that, we multiply by 2 silvers for every 1 magnesium. So times 2 gives us, if we could use all of the magnesium, we could make 0.313 moles of silver. And then the silver nitrate, since that's a solution, they give us a volume and a molarity. So for the moles of silver nitrate, we're going to take the volume, 0.0236 liters. So I converted from milliliters to liters by dividing by 1,000. And you might write that out on a quiz. And then the multiplication, volume times molarity, 0.2056 moles per liter. And I don't like writing the big M for molarity when I'm solving problems because it disguises the units. So we can see our liters cancel, and that's why I converted the volume to liters. Molarity times volume is number of moles, and if we had 0.0236 liters times 0.2056 moles per liter, we find out we have a small amount, 0.00485 moles of the silver nitrate, and then we get 2 silvers for every 2 silver nitrates. Those are the parts of the balanced chemical equation we use to build the mole ratio. And I'm not going to do this on my calculator, times 2 and divide by 2. I know I can make 0.00485 moles of silver if I use all the silver nitrate. So it looks like we have enough magnesium to make 0.3 moles of silver, but only enough silver nitrate to make 0.00485 moles of silver. So that's how much we make. So there's the, in terms of moles, we have answered the question of how much silver can we make. If we want to know the mass of the solid that will form, 0.00485 moles of silver times, I believe it's 107.9 grams per mole. Again, looking over at my periodic table that's handy, I get that's correct. So this many moles times 107.9 grams per mole gives us 0.52 grams of silver would be formed. And that's some solid that we would expect to be present at the end of the reaction. But then we notice the magnesium, we had a huge excess. So we're going to have some magnesium left over at the end as well. So this is the super advanced bonus part where we have to ask ourselves, how much magnesium did we use? So how much magnesium is left? So I take the amount of silver formed, 0.00485 moles of silver, and then I use a mole ratio to say 1 magnesium would be used for every 2 silvers made. So 0.00485 divided by 2. So I'm going to use 0.002425 moles of magnesium would be used. And then if we want to know the mass of the magnesium used, we multiply by the molar mass, 24.31 grams per mole. And we get 0.05895 grams of magnesium used. Right, and we started with 3.8 grams. So squeezing this all on the piece of paper, 3.8 grams of magnesium to start, minus 0.05895 grams used. And we get that we have about 3.7 grams of magnesium left at the end. 3.7 grams of magnesium left. So at the end, we have 3.7 grams of magnesium. We have a half a gram of silver. And if we add those up, what do we get? 4.22 grams. Again, to only the tenths place here. And that's where I probably shouldn't be rounding this to 2 significant figures yet, because we're going to use it in the next number. So if I say my 3.74 grams of magnesium plus my 0.52 grams of silver, at the end I have 4.26 grams of solid, which rounding to the tenths place, 4.3 grams, is about the mass of solid that we have at the end. And so this fairly demanding limiting reagent problem that will really demand that you understand the states of matter of your reactants and products, and that you can have some leftover reactant as well as some product formed. Every one of these steps was fairly simple, but to orchestrate it all together and to come up with a solution might take review a few times. So what I would recommend if you're trying to master this kind of problem is to write the problem down on a piece of paper and then, say, twice a day, work through the solution and see if you get what I got, provided I got it right. And it should take you about 10 minutes to solve this problem each time. The first time might take you 25 minutes, and then once you get it down, you could probably solve it in 10 minutes like I did, and by that time you'll be a black belt ninja at writing balanced equations, converting to moles, using the mole ratios to find out how much product you make and how much reactant you use, and then summing the masses of the solids together to get the total amount of solid left in the reaction. So I hope you find this to be fun, or at least manageable, and if you have any other questions, I'll be happy to make more helpful videos.